that the term is a bit vague, since it has different applications in different sciences, from architecture to software engineering, to software science, to computer science, and so on. But as far as we're concerned, software engineers, UI developers, designers, we're trying to establish accessible communication channels with our end users. So basically, we want to exchange messages with our users. Thus, we're integrating semantic HTML or even external software or hardware like screen readers or specialized keyboards and so on. But you will be fairly surprised if I tell you that the very first accessible communication system was established nearly 200 years ago. So this is Louis Braille. Braille was born and raised in a small city outside of Paris. And as a child, he suffered a terrible accident that left him completely blind. But still, he has excelled his education. He has mastered his disability and finally got accepted to the National School for Blind Youth in Paris. It was back then where he found out that the reading and writing system used by visually impaired people back in the days was a bit, how can I say, unusable, because people were trying to recreate the visual alphabet using ink and fat brushstrokes. So Braille committed himself into the cause of bridging the communication gap between the visually impaired people and the sighted. So at the age of 15, he introduced the Braille system. So Braille is a tactile system. Characters, letters, or symbols are encoded using combinations of raised dots and spaces. As you can see, the users can trace down the letters, also known as Braille cells, with their fingertips. In that way, they can combine them, create words, sentences, and so on. We can safely also say that Braille has introduced the very first binary communication system, and somehow he might be the great-grandfather of digital communications. And Braille system was good. It was actually so good that hasn't literally changed since its birth. Nowadays, it is translated in more than 200 languages, and it has different applications from math to music composition and so on. Soon after his death, his system got widely adopted, and soon after, typographers started publishing books in Braille. They are using inkless typesets and heavyweight paper in order to create the embossed Braille cells. Also, in the early 20th century, typewriters were invented. Modified Braille typewriters to write in a more semi-automatic way. They were using 6 keys in order to recreate the Braille cell, the dots inside the Braille cell, and one more for spaces. By the way, the happy typing lady you can see in the image is Helen Keller. Helen Keller was one of the most famous American authors, an activist about human rights, and also the very first blind deaf person that has managed to graduate college. Finally, our last piece in our puzzle was introduced in late 1980s, early 1990s. These retro-looking devices are called refreshable Braille displays. As you can see, at the very bottom, there's a fixed number of Braille cells, and the users can pair these devices with external hardware like personal computers or mobile phones, or even load text directly into the device. Using the navigation keys at the top, they can browse through the text in a more automatic way. So let's recap. The year is 2020. Organizations and individuals are raising concerns about literacy rates all around the world. And we're trying our best to fight literacy in Africa, Asia, or Latin America. So someone could say that we're in a really good shape, right? Well, actually wrong. numbers and statistics are nearly devastating or heartbreaking. As we speak, there are around 253 million people living with visual impairment all around the globe. Most of them are living within war zones or suffering poverty. We don't have actual global statistics available, but organizations are estimating that around 10% have some sort of access in Braille material. And someone could say that we cannot relate with these numbers, right? Because, you know, we're living in high-end societies in Europe and in the UK, so we can't actually relate with people living in Iraq, Syria, Afghanistan, and so on. And this is really funny because every time I'm making this talk, I'm trying to dig up for some statistics. So according to the Royal National Institute of Blind People, there are like 2 million visually impaired people living in the UK, and just 1% of them is capable of reading and writing in Braille. Imagine that. And if you ask me, it's a real shame, because in April 4th, 2020, 100 years have passed since the Blind March. The Blind March was a huge march for 200 visually impaired people, marched all the way around from Newport, Bristol, Manchester, towards London in order to ask for their rights, in order to ask for equality. And in that they have made the rights being heard. And the very first about visually impaired people has taken place in the UK and actually worldwide. So we have to think ourselves. What did we do so wrong? What's actually causing so much trouble, so much pain, so much unemployment? As a matter of fact, we're lacking of assets. So if you think about it, in order to learn Braille, you have just to practice yourself. You have to recognize, you have to teach yourself to recognize the alphabets and try to read. Of course, we don't have the visual impact in some cases, and it might be harder, but as a matter of fact, books are like super expensive, and just 1% of books available are also available in Braille. Furthermore, Braille displays are like super expensive. They cost from like £500 to up to 8,000. The thing is that the marketplace is so niche that there's no such thing as research and development, and they're incorporating some sophisticated hardware called piezoelectronics. Thus, in that way, there's no such thing as trying to reduce the price. Finally, I said, finally, typewriters are like super expensive as well. And although the technology is a bit obsolete, people are still using them as it's somehow an affordable way of writing Braille. So we have to think ourselves. Imagine that someone hands you this problem and tells you, hey, is there anything that you can do as part of one of the most popular communities in the web industry about this problem? So in that matter, can we somehow help this situation? So for the purpose of this experiment, we're gonna try to prototype a device. We'll try small. We'll try to recreate the functionality of a refreshable Braille display. Nothing fancy. Maybe we can start up with a single Braille cell and move on and try to expand the device as we're going on. So before, it's really important to set up some goals, right? So since I had no prior expertise or experience with hardware development, we want our device to be as easy to build and as possible. And we also want to make it somehow modular in order to expand or reduce the number of the Braille cells. Obviously, we want our device to be accessible. And finally, we will try to reduce the price as much as we can. But how? Is it even possible to prototype hardware these days? So for the purpose of this prototype, we're going to incorporate a piece of technology. Microcontrollers. Microcontrollers are like tiny computational units. They're easy to purchase, easy to hang around. They have vivid communities around them. Arduinos, Raspberry Pis, Photon, Espruino, just to name a few. And for the purpose of this experiment, we're gonna stick up with this little baby. This is the famous Arduino Uno. So basically, the microcontroller comes into a shape of a board, and as you can see, there are pins popping out from the device. So using these pins are labeled with numbers, and using these pins, we can expand the functionality of the board. Since we had no prior experience with programming Arduinos, we will try the hello world of hardware development. So we're gonna try to flash an LED. So as you can see, I have attached the LED, the one leg of the LED in the pin labeled 13th, and the other one on the ground just to power up just to flash up the light. And if you try to write code for Arduino, you will find out that in most cases we're writing C or C++. Arduino comes with an IDE, which is called the Arduino IDE, obviously. And in order to flash the LED, our code would look like this. So at the very first line, we're just allocating the pin number. So we're telling our compiler that we're gonna use the pin labeled 13th. And the Arduino IDE comes with a few functions that are like built-ins. So in the setup function, we're gonna allocate the pin as an output pin. And finally, in the loop function, which is like an infinite loop, we're gonna flash the LED with an internal of 500 milliseconds. And that code actually works. But as I was trying to implement different solutions, and because I had lots of thinking about how I could incorporate different ideas about matching the Arduino with web development or external hardware and so on, I found myself stuck, mostly because, just to be honest with you, I haven't written C since my college years. But luckily, though, I stumbled upon a project called Johnny 5. So Johnny 5 is an IDE and a framework which have been developed by a Canadian company called Bocoup, and us to write Node.js for microcontrollers. We can write Node.js code, compile it, and execute it on different microcontrollers. So using Johnny 5, we can recreate the previous example as simple as we're gonna allocate the Johnny 5 module. Afterwards, we're gonna create a new board. And when the board is ready, we're gonna create a new instance of a built-in LED class, which actually listens for the pulse from the pin labeled 13th. And finally, we're gonna blink the LED. And someone could say, what's wrong with you? What's your problem when you're trying to write code? You're trying to run JavaScript on a microcontroller. So as a matter of fact, if you're trying to write some code for microcontrollers, for hardware, you will find out that in most cases we're dealing with events. So the controller itself is just a blank board. It does nothing. You have to attach external modules like buttons or lights or even sensors. So you have to handle events all the time. And JavaScript is an event-driven language, was born as an event-driven language. So it means that handling with JavaScript feels way too natural. Also, since we want to create rich experiences, we can use modules that are up in the registry right away. So we can pair our development experience with utility libraries like Loda. So we can pair our device with the web Bluetooth API and so on. Everything that's in the registry we can use in plain Node.js code. And finally, and also, we can use the Johnify framework in order to target different devices. So based on the device, we can directly execute the code into the controller, like the Raspberry Pis, or as in our case, we can remotely control the device using a protocol called frame data. And this is really important. So because even within the same family, boards are different from one another. So the Arduino Uno is totally different, has different hardware specifications from the Arduino Nano and so on. And finally, we have to admit that hacking around things lives inside our DNA. 10 years back, we have been the skirting kids popping alert boxes in browsers. And somehow jQuery came up, and we have started recreating the web, creating more vivid and rich experiences. And somehow someone thought, hey, we can run JavaScript in the server. So Node.js came up, and people kept hacking around. We have talked about React Native. We can run JavaScript everywhere, and that's a key difference from other communities, because we're trying to expand our vocabulary, we're trying to expand our mind. And since coding, we have to think about designing. So this is a very early prototype about how the Bragg cell looks like. Please don't judge my skills in CAD, they're awful. But the very basic idea is that we have like 6 pins that are just popping on demand. And one Bragg cell consists of 6 pins and the enclosure. In that way, we can easily attach or detach the Bragg cells into the device. And since I got my design, I used my 3D printer in order to fast prototype everything, which was really magnificent, because I could try different modules, or I could create an enclosure for my actual device. So iterations were really, really, really fast. And finally, we know the brain and heart of the device. We know how to code it, have the external. But how can we actually, translate code data into motion? So I tried myself different modules out there, and I have decided to go up with this little fellow. So this is a solenoid. Solenoids are like tiny actuators, electromagnetic actuators. They're mostly used in electronic or electronic watering systems. And I have purchased like 6 of them. So using 6 of them, we can recreate the Bragg cell. And they're like super cheap and a bit bulky, but they're working outside of the box. So now that we have our framework, we have our hardware, we have the external modules, let's bring everything together. So the thing is that, as you can see on the left column, I have the actual alphabet and all the symbols of the English alphabet. In the middle, you can see the Bragg representation of the character. And finally, on the right side, I'm using an array with 6 positions, because Bragg cells are allocating 6 positions. So I'm using ones in order to encode the raised pins, for idle pins. Unfortunately, the Bragg alphabet is not deterministic. In that way, I had to create a Bragg map in order to match the alphabet with the appropriate binary representation. And also, I have created a tiny utility function that actually takes a character and returns the binary encoding of that character in Bragg. Next up, we have to create the cell class. As I told you before, I created a device where each cell is touchable. So in the cell class, the Johnny5 module. And in the constructor, we are just asking for the pin we want to allocate. So since we have like 6 pins, each pin, we have 6 pins inside the cell. Each pin corresponds to a digital input and output pin in the Arduino device. So we want to allocate 6 pins from the device in order to control 6 pins, 6 actuators in the Bragg cell. And also I have created a private method which is called draw, which actually takes a character and based on if the solenoid is raised or in idle position, decides if it has to force the pin up or down. And this is actually where everything comes together. So once again, we are allocating the Johnny5 module. We are requiring the cell class. We are creating a new instance of the board. And when the board is ready, we're just drawing the letter A. As you can see, since the cell allocates pins from 13 up to 8. So I know most of you are quite bored right now, listening a guy talking about hardware and JavaScript. So I want to bring up something like a live demo here. So as you can see, basically my entire presentation runs inside my browser. So this is like JavaScript and HTML. And as you can see on the right side, I have a brilliant typeface called Bragg Neue, which will give you a visual representation of the characters from the Bragg cell. And up here, I have a live feed from my camera. This is like a tiny Bragg cell. And let's give it a try. I'll try to write something more fascinating rather than hello world. Like, hi, beautiful people. Cross your fingers, so let's give it a try. Okay, here we go again. Cool. Let me fix this one. Okay. So apparently our prototype works. Actually, that was my way of trying to, that's how I taught myself Bragg in the very first place. So let's bring up some results. As I told you before, I had no prior experience with hardware development. Even so, the Arduino community, it's like super vivid and informative. It was really rough for me, but it was really easy to bring up the components and bring up the whole device in a weekend or so. Also, developing the application with Johnny5, since I'm using JavaScript all the time, was feeling like a breeze. I had instant feedback from my coding experiment, and also all the components were purchased. Nothing fancy here, nothing sophisticated. All the components were purchased from a hobby store. Also, since we can easily attach or detach external pins or hardware or even different modules onto the board, that means that we can expand the size of the device itself. Although we're a bit limited because the digital input and output pins from the Arduino are limited by the nature of the microcontroller. And finally, we can bring up something like up to 12 cells that costs around $40, which is like super awesome. If you think about that bright display startup from like $800. But we're not done here yet, because for the past 2 years, I'm trying to think about the second version of the actual device, because I want to create something that's more commercial, more rigid, more easy for users to understand, and make it somehow part of their everyday usage. So I have created some study groups with visually impaired people, and I got some great feedback. And as we speak, I'm trying to improve the design a bit. And also, I don't know if you feel it, but the actual solenoids are energy inefficient because they require high voltage. So, and actually they're a bit bulky. So I'm trying to incorporate a different design that actually works with tiny stepper motors. These motors are used controlling the lenses in cameras or micro robots. So I think that I can further reduce the size and the cost of the actual final product. Furthermore, I think that I can use different modules or components. So I was running the device directly from my command line, but I think that I can create more rigid experience, web APIs, or even trying to attach different modules like sensors, and try different experiments with the actual users, the people who are gonna use the device every day. And it's weird because I have made this talk like so many times, and I have talked about this idea like a lot, and people were like, yeah, that sounds amazing. You should try to get up some funding, or you should try to build up something that's commercial and people can use it every day. But that's not actually the case, because I wanted people to feel about the need. And I have experienced so much. I have found out that people were trying to, when people are introduced to the IoT world, are trying to create stupid applications like incorporating their Alexa or switching their lights, or maybe, I don't know, controlling their fridge. So in that way, I have decided to open source the entire project, the schematics, everything that you can do, that you can make up this device in your house in a weekend with your children, or even inside the class with your students. And that's really interesting because we can raise about these people out there. And finally, I'm closing. Yeah, I know. And finally, if there's something that you can take away from this talk, it's the fact that we actually care. And if someone tells you that you can do this or that, just, we got your back. This community has your back. And you have so many great people among us that are raising the bar so much. So try to do your best. Stay healthy, everyone. And thank you so much for your time and patience.
It's amazing. You know, the actual Institute for the Blind is not far from where I live. It's like 5 minutes away. So if you are interested, when you come to London in September, let's hope everything goes back to normal.
Yeah, I know. And they actually celebrated 100 years from the Blind March this April, and there is a video online. You should check it out to find out how people are living in the UK. Yeah,
amazing.
Please do that. Thank you so much.
Thank you very much. So we can have a chat about it later, but because we need to catch up with the time, we'll just quickly jump back with Mike to finish off with his talk. It was amazing. Like I cannot really tell you